Hello, welcome to the data channel. So you might be wondering, even after moving to Spark, Hive, or Databricks, your big data queries might be running slower. So the problem might not be your cluster size, probably. It might be how the data is organized. Because if it is a cluster size, so that is one part of the problematic situation where you have to add more nodes, worker nodes, or master nodes, or you need to upscale the cluster size. But most often, the issue lies with how data is organized, or how the data is stored. So in this video, we will break down the three powerful techniques that every data engineer must know. That is partitioning, bucketing, and clustering. So you will learn what they are, how they work under the hood, and most importantly, when to use which to optimize the performance and reduce the cost. So whether you're preparing for data engineering interviews, tuning queries in Spark, or working with warehouse like BigQueries or Snowflake, this video make this concept crystal clear. So let's get started. So let's understand the partitioning. Partitioning simply means splitting a large data set into smaller, more manageable parts based on the values of the column. For example, in a sales data set, you might partition the data by order date or a region, right? And basically how it works is, like, suppose if you see an example here, this is how a table can be created, right? Like a table can be created and the partition can be defined. But coming to how it exactly works, right? Behind the scenes, the partition creates the directory structure where every partition corresponds to a unique value. So like here, like suppose if you are partitioning by order date, so then like in the behind the scenes, you can observe in the sales is a folder, and in the subfolder, it has created a subfolders for each particular dates, because you're creating order by date. So if there are 365 days data in a year, so then there will be a order date equal to those 365 folders, those subfolders you'll be seeing here, and the respective data of that each date, individual date, will be stored in that particular subfolder of a particular date, right? So if your partition, it depends on like date. So usually it will be you by date. You can choose by region, by country, etc. So the queries filtered by date will only scan that partition. So that is the whole advantage here, right? So suppose you are writing a query where order date equal to XYZ, or country equal to XYZ, right? So then it need not scan the entire data, because the entire data might be in TBs or GBs, right? So it will just go to that particular folder because it knows where the data lies physically. So it is just going to that partition and hitting the exact right partition, and it is getting the data. So you can imagine if there is 10 years worth data. So instead of checking 3650 folders, so it will just need to check one folder and get the data, and you can see the amount of data scan that will reduce, and how much the performance improvement can be achieved with this, right? So this is called the partition pruning. So basically, it is we are trying to prune here by creating a separate partition for each individual dates, or it might be any attribute. So it is again a developer choice. So based on the reporting requirement, if your reporting requirement is based on a particular targeted columns, you can choose that as a partition column, right? And basically it can drastically improve the query performance. So that's the whole intent here. So let's understand the pros and cons part of it. Okay. So that means the benefits. What are the benefits that you're getting by creating a partitions? Queries runs much faster. So since they only scans the relevant partition. Okay, that's what we were discussing. And it reduces the input output cost. So here we are not just it's not just about making the queries faster. Okay, it is all about saving the cost, and cost also, because you are reducing the input output operation. Previously, if the query is taking 30 minutes, now it is taking 3 minutes. So you can imagine how much compute, or how much input output cost it has saved, right? And it might be 10x, 20x, or whatever. and also makes large scale queries more efficient, because you're talking about here these all the concepts whatever we are talking, whether it's partitioning, clustering, or bucketing. So these are all concept for the huge data. So this is doesn't make any difference, or doesn't make any sense if the data is in like thousands or 10,000s, or if the data is in some MBs or several GBs, right? So we're talking about where the data is in millions, billions, and the rows are like, and the memory it takes is maybe couple of GBs or TBs or more, right? So in that case, so all these performance optimization techniques will make a difference, okay, or make an impact, okay. And what else you can think of advantages, and it also keeps the data well organized. So that is also important, because if the data is well organized, if you want to apply any kind of archival strategies, you want to archive the data which is older than XYZ date, right? So you can just go and hit that particular folder and archive it. Or if you want to perform some kind of access control at a folder levels, so that also you can perform when you have already partitioned the data. So that's also one of the benefit of partitioning. And coming to the but definitely there will be a trade-off when you are doing anything, right? So here, if the partition columns has too many unique values, okay, you end up with thousands of tiny partition, causing a small file problem. So small file problem is one of the biggest problem in big data or data engineering world. So you can read more about it, but ultimately what we are talking here is like if there are too many partitions, okay. Suppose if I'm instead of creating a partition based on the date, if I create a partition by mistake, also if I create a partition based on the timestamp, so then you can think of like if there is a transactions coming every hour, there might be 10 transactions. So then you can think of like 24 hours, there might be 240 transactions. So per day, it will be creating 240 folders instead of one folder. It will create 240 folders and per day. So instead of per day, you can calculate per year or so how much folders it is creating. So that's where it is very critical to choose the right partition column. It should not lead to the small file problems. So we need to analyze the column. It should not be it should have the uniquely distributed value, right? And it should not be creating too many small file problems, right? So that's also one of the key element to consider. And also, if you pick the wrong column to partition, queries won't actually benefit from it. Rather, it might worsen the queries. So choosing the right partition key is very critical. Okay. So this is all about the partitioning. So now let's move to bucketing, another optimization technique that especially useful in Hive and Spark areas. So here, bucketing means splitting a table into fixed number of equal sized files. Fixed number of equal sized files based on the hash value of a hash of a particular column. For example, if you bucket by customer ID, so into 8 buckets, so each row is assigned to one of the 8 buckets based on the hash function. Okay, so you're basically it's creating multiple buckets. Okay, so that bucket, the number of buckets can be controlled. Okay, whether you want 8 buckets, 10 buckets, or whatever it is. And so whether if you're choosing customer ID, you can choose employee ID. So based on that IDs, so it will have some hash function, okay, which will decide which bucket that has to go, okay. And if there are 1,000 records, so all the 1,000 records will be equally distributed in the 8 buckets or 10 buckets, whatever the number of buckets that will be chosen. So this will be completely taken care by the hash function. So this is a function which will choose which bucket a particular record has to go and land. Okay. So that is a hashing algorithm that will take care of it. So, and how it works, the important point is row with the same value will always land in the same bucket. Okay, this makes it extremely helpful when performing joins, because both tables bucketed on the same key with the same number of buckets can easily be joined more efficiently, and the less data shuffling will take place, right? Because otherwise, if they are into multiple buckets, right, so the data shuffling has to happen So that is a key important thing here. And as you can see, this is an example, right? Like we are doing cluster by customer ID into 8 buckets. So this syntax, whether it is like we saw the syntax of partitioning, and now we are seeing the example of bucketing. So this is like the syntax might change when you're choosing SQL Server or when you're choosing other database systems. So here we are talking about this syntax, which is Hive or Databricks Delta table specific or Spark specific. Okay. So the syntax might slightly change when you are using other data warehouses or databases. But we are choosing these examples because these are big data formats, Spark and Hive and Databricks Delta tables and BigQuery. So this syntax is more suitable for those kind of data formats. And coming to this customer ID, so we have chosen customer ID and we are telling it to bucket it to 8 different buckets. So if there are 10,000 rows, so all 10,000 rows will be equally distributed into different 8 buckets, and which row has to fall into which bucket out of these 8 buckets. So that will be completely decided by the hash column. So that is where it is hash column mode number of buckets, right? That matches the number of bucket here. So rows with the same customer ID will always land into the same bucket. So that's the key important thing here, right? Because if the customer is performing any say transaction, and every transaction customer ID is coming, so row with all the customer ID, the customer ID, if a particular customer called 100, customer ID called 100 is doing some transactions of 10 transactions per day. So all these 10 transactions of that particular day will land in the same bucket, because any analysis or any kind of joins operation that is performed based on this ID, so there will be less shuffles based on that. So now let's move to the pros and cons of bucketing. So what are the benefits? So it reduces the shuffle during joins, which is one of the most expensive operation in big data. So wherever you talk about joining the data, so then you have to think of whether the data is properly bucketed. Okay. It means it also makes random sampling easier and more accurate wherever you're performing machine learning use cases, or wherever you want to get the random sampling of the data. So then it is more accurate. And since bucketed tables store data deterministically and repeatedly, queries are often runs faster. Okay, it's because it's more predictable. And but there are some drawbacks also. The number of buckets is fixed at a table creation. So if the data significantly grows, you may need to rebuild the table to change the bucket count, because the bucket count is always fixed. So it adds at the right time, because hashing and sorting must be done before writing the data into buckets. So that is a prerequisite. And compared to the partitioning, it is less flexible if your query filters on ranges or high level columns. So then it might not perform better when compared to the partitioning. All right, let's move to the clustering concept. So clustering means organizing the data inside a table based on one or more columns. That is what we call it as a clustering, and it's known as clustering key, basically, right? Unlike partitioning, cluster doesn't create a separate folders or directory, right? Instead, it arranges data more efficiently within the storage file themselves. Okay. Like for example, if you see here, we are creating a sales table, and we are creating a partition by, that is anyway partitioning, but cluster by product. We are creating a cluster by product here. Okay. So what it is doing is, when you cluster by a product, okay, so data is stored like it'll group by, it is like a group by, it will take all the distinct products. Okay. So all the data of a particular product, if the product is say television, if a product is say mobile, if a product is say any item. So that item wise or the product wise data is grouped, and they are stored in a particular cluster. So why we need to do this? Because again, it depends on like storage. You are making the storage. So data in the table physically correlated or co-located based on the clustering keys. So again, it might be based on the country or date. So here, if you take example of we are clustering by product. Okay, data is partitioned by order date and clustered by product. So the data is data related to a product one. So if there are 10 products, for example, it will create 10 different locations for each products, and data related to one product are stored very co-located based on the clustering key, right? So that will internally have that clustering key, and based on that, the data is related to one product are core co-located. That means in the memory, so they are stored closer to each other. So that means when the data scan is happening, right, the engine can quickly skip the irrelevant blocks of the data and scan only what is required. Okay, so that's about clustering. Next, moving on, we'll see what are the pros and cons. What are the advantages of clustering is it reduces the amount of data scan, which means faster queries and lower cost. It works well with high cardinality columns like customer ID and product ID, where partitioning would create millions of tiny folders. So that's a key difference. So this I want you to note this particular point. So the key difference here is if you talk about partitioning, right? So partitioning it will take that column, whatever you are defining as a partitioning column, and it will go and create those many number of partitions. Okay, and so physically those many number of partitions are created, and because so many partitions are created, what happens is like when you are scanning the data, like it might lead to the or it, when the partitions are getting created, so it might create a lot of small files, like if you choose IDs or if you choose timestamp, etc., that we have seen, right? So, but when you come to clustering, so that problem will not be there, because clustering is not upfront going and creating the number of folders, right? So it is not creating the folders. What it is doing is it is going behind the scenes and storing the, like if you talk about the customer ID and product ID in this case, right? In this case, if you choose customer ID and product ID, so it will, which is a high cardinality column, what we call as. That means they can have repeated values. So even in this case, what happens is the customer IDs which are related, okay, that will be stored like next to each other in the memory, so that it can be faster to read or access. But it is not physically separated. It is stored in a co-located manner. So that is why you can use clustering for high cardinality column, but partitioning we cannot use for high cardinality columns. So, and other advantage of using clustering is, and it can complement partitioning. So giving you the best both of the word, you can combine clustering with partition to get the best out of the both words. And but also it has a limitations. Clustering has a limitation, like over time as a new data gets added, the clustering might become less efficient, leading to performance degradations. So fix that, you might need to recluster the table, which adds the storage and the compute cost. And unlike partitioning, the performance gains aren't always predictable because it depends on how selective your queries are and how the data is co-located within the storage systems. So clustering is best when queries filters on high cardinality columns, or when you want a fine-grained performance tuning alongside partitioning. But it's flexible, powerful, but it requires some maintenance compared to partitioning. So I would recommend when you're using clustering to be very cautious because there is a maintenance involved. You have to completely like keep on revisiting it. So there is a it is not as simple as partitioning, right? So partitioning is much more like flexible and powerful, right? Where we'll be discussing about the key differences. So the key differences is partitioning works at a directory level. So it is best when you filter data at a low cardinality columns, whether it might be date or it might be a range, right? It is at a directory level. Okay. And the query engine can skip the entire folder, which is called as a partitioning pruning. So that is the concept of pruning, one of the optimization techniques. Where when it comes to bucketing, so bucketing works at a file level. Data is split into fixed number of buckets using a hash function, and it outperforms during joins and sampling, since the engine knows exactly where data where rows within the same keys are stored. Okay, when coming to clustering, so clustering works it works inside the storage. So it physically orders the data by choosing the columns, making queries on high coordinated columns like customer ID and product ID more efficient. Unlike partitioning, it doesn't create any folders. Rather, it rearranges the data blocks. And if you talk about like large range filters, date range, etc., so that is where the partitioning works better. And this is we discussed. And coming to the flexibility part of it, clustering is a highly flexible, and we can recluster dynamically. And so partitioning is not so flexible, and also bucketing is not so flexible, because once we choose the column, here we choose the number of bucket, but and here we choose the number of columns. So then that will be fixed. So if you want to rebucket or repartitioning, here you need to change the column name. Here you need to change the number of buckets and recreate the entire bucketing and partitions. And so the downsize we discussed. So small file issues might come in partitioning, and bucketing is rigid when rigid bucket count can happen, and clustering. So we might need reclustering. So these we discussed the downsides already. With that, we will come to end of this video. So the real power comes when you combine all of these three wisely. For example, partition by date, bucket by customer ID, and cluster by product, for example. So that way your query runs faster, your cost go down, and your data stays well organized. So rethink about all of these things, and take like better to try practicals with this. So if you have any comments, if you have any comment suggestions or questions, please feel free to comment in the comment section. So thanks for watching.